Hello everyone, it's Jay Wengrow, and I'm here today with a little lesson on something called recursion. Now recursion at first can be slightly intimidating and mind-blowing, but just keep in mind that it only takes a ton of practice. But once you get that practice, you get used to it. So let's start with a very simple example. I'm going to make a Ruby method called blah. In it, I'm going to print the word blah to the terminal. Then I'm going to call the method blah within the blah method. Can you guess what will happen when I run the blah method? If you guessed that we'll have an infinite loop, you're right. So I'm scrolling up here, you could just see there's tons of blahs. Eventually, the computer gives up with this error called stack level too deep. And we will get to what that means momentarily. That, my friends, is recursion. Recursion is when a method calls itself. In this case, recursion led to an infinite loop, which of course will make you wonder, why on earth would we learn recursion? Recursion seems to be a bad thing. So recursion could be a bad thing, as in this case, where it's an infinite loop. However, recursion can also be a good thing. In fact, recursion can actually serve as a substitute for any loop. Anytime you might use a loop to code something, you can actually use recursion as an alternative. Let's see what I mean by that. We're going to make a method called blastoff, which is going to accept a number and then count down to 0 from that number. So we'll use a regular loop. I'll use a while loop. So while number is greater than 0, we're going to print out the number, and then we're going to decrease or decrement the number by 1. And that's it. So again, if we call blastoff 10, what that's going to do is it's going to accept the number 10. While number is greater than 10, we'll print the number. Then we will decrease the number by 1. So in this case, it will be 9. We go back to the top till we hit 0. So let's see what happens in the terminal when we run that. We get 10 down to 1. If we wanted to actually hit 0 also, we can say greater or equals to. So we get 10 down to 0. Perfect. So that, of course, is quite simple if you're watching this video. However, we can also accomplish the same thing using recursion. Let's see how. I'm going to get rid of the loop, and instead, we're going to say puts number. So we're going to print out the number. So in this case, we'll print out 10. And then we'll say if number is greater than 0, then let's call the blastoff method. So here is our blastoff method calling the blastoff method on whatever number is minus 1. Let's run this, and we'll see that we get the same exact result of counting 10 down to 0. Let's analyze how this works. So we start with blastoff 10, we print out 10 on line 2. If number is greater than 0, and indeed 10 is greater than 0, we say blastoff number minus 1, which is the equivalent of saying blastoff 9. Now that immediately triggers blastoff 9. Blastoff 9 prints the number, which in this case is 9. If number is greater than 0, which it is, we trigger blastoff 8, where we print 8 and eventually trigger blastoff 7, etc. Now, why doesn't this go into a tailspin of an infinite loop? That's because we have this if statement here on line 3. Only if the number is greater than 0 will we do recursion and run the blastoff method from within the blastoff method again. However, when we call blastoff 0, what that does, so imagine we started from 10, which calls blastoff 9, blastoff 8, blastoff 7, blastoff 6, blastoff 5, blah, 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 blastoff 2, blastoff 1. blastoff 0. So when we call blastoff 0, that prints 0 here on line 2. And then we say if number is greater than 0, 0 is not greater than 0. So we don't run the recursion. The recursion ends. We don't end up with an infinite loop. Now, to explain one level deeper of what the computer is actually doing here, because this is a little confusing. Every time recursion happens, every time the computer calls a method from within a method, it has to keep track of all the methods that it's still in the middle of. So let's start from the beginning. Actually, in this case, let's do blastoff 5 for the sake of time. So if we call blastoff 5, what happens is, again, the blastoff method gets called. On line 2, we print out 5. Then we say if number is greater than 0, which it is, blast off 4. Now, at this very line, right where my cursor is, before we even hit the end keyword on line 5, Ruby immediately triggers blast off 4. But really, if you think about it, we're still in the middle of blast off 5. So what Ruby does, and most programming languages do, is keeps in something called a stack, which is basically a list. It keeps track that it's in the middle of blastoff 5, and it's up to line 5. Line 5 is the next line that it's going to execute. But we keep that on hold and trigger and actually execute blastoff 4. So we're not even done with blastoff 5, but we're already launching blastoff 4. In blastoff 4, we print the number. If number is greater than 0, 4 indeed is greater than 0. So blastoff 3. Now we don't even get to the end of blastoff 4, but we already trigger blastoff 3. But to keep track that we're still in the middle of blastoff 4, Ruby keeps in this stack, in this list, blastoff 4, line 5. It does this again for blastoff 3, blastoff 2, blastoff. So then let's just walk through. When it calls blastoff 2, prints 2. If number is greater than 0, it is. Then we call blastoff 1. And we keep track of the fact that we're still in the middle of blastoff 2. Then we print 1. Then we have to keep track of the fact that we're in the middle of blastoff 1. And then we call blastoff 0. Now watch what happens carefully when we launch blastoff 0. We launch blastoff 0. Now again, when we're launching blastoff 0, we're still really in the middle of blastoff 1, which in turn is in the middle of blastoff 2, which is in the middle of blastoff 3, which is in the middle of blastoff 4, in the middle of blastoff 5. Now when we're up to blastoff 0, we print 0. If number is greater than 0, it's not, so we're done. We actually get to line 5. This is the first time, only within blastoff 0 do we actually get to the end of line 5. So we're done. But then Ruby looks at the stack, and it says, I'm really not done. I have to go back to all of these blastoff methods that I'm in the middle of running. So the way a stack works is that when taking things off the stack, it starts at the end. So it says, okay, Ruby says the next thing I need to run is blastoff 1, line 5. In this case, it's just a simple end keyword, and then we're done. So Ruby takes that off the stack. Then it says, okay, now I need to complete running blastoff 2, line 5, which it does. Takes that off the stack, completes running blastoff 3, completes running blastoff 4, completes running blastoff 5, and then we're done. But by the time we're done, we'll have printed out 10 through 0. So here you can see that you can use recursion as an alternative to a loop.